Welcome to this special edition of the New Stack Makers on the Road. We're here in KubeCon North America in
Detroit Rock City!
Discussions from the show floor with technologists giving you their expertise and insights to help you with your everyday work. Amazon Web Services is the world's most comprehensive and broadly adopted cloud platform, offering over 175 fully featured services from data centers globally. Millions of customers trust AWS to power their infrastructure, become more agile, and lower costs.
Hello, everyone. Welcome to this on-the-road edition of the New Stack Makers podcast. I'm Heather Joslin, features editor at the New Stack, and we're coming to you from KubeCon plus Cloud Native Con North America here in Detroit, the Motor City. Detroit's a city that was built on making things and on the robust supply chains that delivered parts and shipped out gleaming new vehicles, and still does. Today we're going to talk about the software supply chain and how we keep that safe, and that's an increasingly tough challenge. We're joined today by two guests who are working to help developers secure the software they make. We're joined first by Aeva Black, who currently works in Azure's Office of the CTO and holds seats on the board of the Open Source Initiative on OpenSSF's Technical Advisory Council, and a shadow seat on the board of the CNCF, the Cloud Native Computing Foundation. Welcome, Aeva.
Thanks so much for having me.
Great, and we're happy to have you join us. And we're also joined by Chris Short, a senior developer advocate at Amazon Web Services, AWS to its friends. Chris is a Cloud Native Computing Foundation ambassador, Kubernetes contributor, and upstream marketing team member. You may know him from the popular newsletter DevOps-ish, which he founded. Welcome, Chris.
Thank you very much for having me.
And today's on-the-road episode of Makers is brought to us by our friends at AWS. Let's start with this. Why is the software supply chain in increasing amounts of danger? And what are some of the factors that are making it more dangerous?
Well, I've been doing open source for, I guess, about 23, 24 years now. And in that time, we've seen so many more people contributing, so many more companies participating and consuming open source. And especially in the past 5 years, a really exponential growth in all of that participation. It's wonderful. But a lot of the best practices that the older communities, Debian, Linux kernel, Red Hat, had developed, those best practices that helped to secure those sort of foundational projects weren't replicated as much by modern tooling, by modern projects, which are much more focused on agility, go fast, build community, rather than build secure software. And now we're playing catch up, right? So a lot of sort of less than ideal practices have taken root in the past 5 years. We're trying to help educate everybody now.
Okay.
Yeah, I think the biggest thing to take away is that if security is everybody's job, it's nobody's job, right?
Yeah.
So we've gone through this evolution where, just develop secure code and you'll be fine. There's no such thing as secure code, right? Like there's errors in the underlying languages sometimes, right? Like we see vulnerabilities in everything. So there's not such a thing as secure software. So you have to mitigate and then be ready to defend against coming vulnerabilities.
Okay. We're hearing a lot about zero trust. What is zero trust?
Frankly, it's yet another buzzword. But the sort of principle it's trying to convey is don't have like a single boundary around your network for zero trust networking, right? The same applies to other domains as well beyond networking. Verify everything at every step of the way. So have a policy engine that's verifying things that have already come through your firewall, for example.
Okay.
Coming from an infrastructure side, for me, it's trust but verify, right? Like I want to make sure that yes, I think this is secure, but I want to write a test to, validate that this thing has gone through attestation, this service has gone through all of its, steps and processes. But sometimes the hardest part is creating those steps and processes and then finding the tooling to implement whatever it is you want. That's another challenge.
What are some of the most common mistakes you see developers in particular make that make the supply chain less secure?
These days, I think a lot of the mistake, frankly, is companies especially small ones or not the big enterprises typically, are just pulling software directly from upstream. They trust a build someone's published. They don't verify. They don't check the hash. They don't check the signature. They just download, a Docker image or a binary from somewhere and run it in production. That exposes them to anything that's changed upstream. If upstream has a bug or a network error in that repository, then they can't update as well. Companies and developers should have an internal staging environment. Pull in, verify, trust, but verify that package you got from upstream before pushing it to production, or even better yet, be able to rebuild it yourself in case you find a vulnerability and need to carry that fix in your own environment while working with upstream to get it merged. That takes more time. So ideally, trust upstream, verify it as you pull it in, and have the ability to patch it yourself before moving it to your own production environment, and then push that work back upstream.
And having that whole build environment actually firewalled, I think, is an amazing concept, right? Like, don't let it call out to some things that are not things it calls out to. Run a DNS log in your environment for a little bit, create those safeguards of, oh, you want to pull a package from not an approved source or not a trusted source? Sorry, not going to happen, right? Like, not in your production build environment. But also, if somebody does get into that production build environment, they can't do anything, right? So if that is compromised, they can only pull from official sources. So they would have to have something ready to go, already hijacking some, package or some name like that, namespace of some sort, just to pull off, a convincingly hard hack of a system that is vital to your implementations of software.
I wanted to, something you said about making sure that they patch things if they pull into an internal environment, they can patch things. We hear about the skills gap and that there aren't enough people for these jobs. Is that part of the problem, that why things are more dangerous now? That are fewer, are there enough people who know how to fix things that they pull from these repositories?
We do hear a lot about the skills gap, especially right now, the skills gap in security, right? There's not a lot of programs teaching cybersecurity or really security best practices. As Chris said, if it's everybody's job, it's nobody's job. At the same time, every developer, every person who does DevOps, it's their responsibility to understand the stack they're using. And I think we don't really teach as much as those of us who learned a long time ago, the lower layers of that stack. And how to understand whether or not those are secured as well.
The lower layers of the stack are vitally important, right? Like, Aeva and I were working on something in Seattle months ago, and we went and pulled an S-bomb for a project. The instructions didn't work first. We submitted a patch, and then when you pulled down the S-bomb, there was glaring omissions, right? Like, there was things like the language implementations from the standard library.
The S-bomb was shallow.
Right, it was
only
very
went
shallow.
one or two layers down, but we know those projects have dependencies, which then
Will
go
have
across a
vulnerabilities.
language boundary to other dependencies, and we need to track all that way.
Right. We need to see our languages as, they're also vulnerable too, right? Like, the standard library is part of our build system, and treat that as something that can be very vulnerable.
Yeah. We learned with log4j that whole situation. Are there other practices in addition to, checking and trusting and verifying and like testing something out in an internal environment that you think more teams should be adopting?
I always say, continuous learning is what we do here as a job.
Yeah.
If you're kind of like, this is my skill set, this is my toolbox, and I'm not, willing to grow past that, you're setting yourself up for failure, right? So you have to be able to say, almost at a moment's notice, I need to change something across my entire environment. How do I do that? It changes your way of thinking about production environments completely.
Yeah.
Because you're optimizing for this scenario of another heartbleed, another log4j, the next thing that comes along. So...
And we know there will be a next.
There will always be a next, right? Like, Kubernetes has had vulnerabilities. For example, like every project here at KubeCon has had probably vulnerabilities they've had to manage at some point.
There is no such thing as perfectly secure software.
Yeah.
And
Right.
that's a good point. And I think asking for secure software as a like procurement process point is just laughable in my opinion, because that doesn't exist. You're asking for something that's not possible.
What
Yeah.
matters much more is your ability to respond to vulnerabilities.
Bingo.
To identify where they are, what's affected, and how fast you can ring fence that, triage it, and apply a patch. That is the critical aspect of security in a lot of these environments, is how fast can you respond, not is it perfectly secure, because that doesn't exist.
Yeah.
Yeah. Is it perfectly documented? No, you know that it's not, right? Like,
To your question, for an organization, not just upstream projects, having the knowledge and skills in-house to be able to respond to everything you're using, right?
Yeah.
That's the crucial part. Not just downloading a package off GitHub or off Docker Hub or PyPy and trusting it, but actually have your developers given enough time, enough training to know how to fix it or deal with it if something is found that's vulnerable.
Yeah.
and your developers are already overwhelmed.
Yeah.
So you need automation to help you. And you need that automation to have a good signal to noise ratio, which has been the hardest part right now
Absolutely.
with everything. It's
Absolutely.
just,
And S-bombs are just even more noise.
yeah, S-bombs don't necessarily fulfill the goal of, oh, there's this vulnerable thing in Golang, you can't fix it.
Yeah.
You know, right? Like you
Yeah.
have to wait for the next thing to come along. But if it doesn't even identify, hey, there's a new version, what good is that, right? Like an S-bomb tells you what's there, not what you need.
Yeah.
You know, right? Like, can it give you, vulnerability information? Not. It's hard to pull out, right? Like,
Yeah.
it's not necessarily formatted in a great way for action.
Not
Yeah.
formatted consistently. The depth isn't consistent, right? Right now, the NTIA, it's a U.S. national body, they've defined the minimum viable elements of an S-bomb, and it's a depth of 1, right?
Yeah.
All of our software has dependencies. Many projects have dependencies 10, 20, 30 layers deep. And so if your S-bomb only goes 1 or 2 layers, you just don't have enough information to know if there's a vulnerability 5 or 10 layers down.
Yeah. And there's nothing you can act on, right? Like, the biggest thing for ops teams or security teams is actionable information,
Right.
right?
Absolutely.
Like, great, something's vulnerable. Where? Right?
Yeah.
Like, okay, I know that this software package, where's it installed? It doesn't answer that question, right? Like, there's all these questions that still have to be answered after the S-bomb and after the S-bomb is improved upon enough to be actionable.
Yeah.
That was the biggest feedback I heard from teams across the world around the Log4j incident. Right? We knew it existed. We knew the risk.
Mm-hmm.
People had a hard time finding it in their own environments. People were scrambling. And
Yeah.
then asking vendors to say, hey, is this product that I've racked a physical product? Does it contain Log4j? Does it have a JVM in it? I don't know.
Yeah.
So answering these questions to give defense and incident response teams better signal to noise ratio to identify if some component in their system is vulnerable or is affected potentially. That's a big part of our goal.
Okay. Well, talking about S-bombs brings us to some of the new developments. There have been, like last year, Google introduced the Salsa framework. I know you spoke at KubeCon Europe at the Open Source Summit on GitBomb, which I want to ask you about in a second. What are some, do you think, are some of the most promising new developments that you've seen in the supply chain security field?
I mean, to be honest, like, as far as like things I'm happy about there being some effort towards user education, but there's not a lot right now that's getting people actionable data. It's a lot of noise still, and we need to refine these systems well enough to know that, like, just because I have Bash doesn't necessarily mean I have every vulnerability in Bash, right? If I have a certain version of Bash that's patched and you can identify that, don't flag it. Like, the security vendors, I feel like, need to do a better job of moving teams in the right direction as far as action. I was at DevOps Day Chicago a few weeks ago, and I had an open space called Container Conundrums Tell me your pain points around containers.
Yeah.
And the whole room admitted to not using least privilege, not using policy engines that are available in the Kubernetes space, right? So there's a lot of complexity that we've got to help people understand the need for it and the how to implement it.
Okay. And I want to ask you about GitBomb. Can you give us a sense of what that's about and how that fits into all of this discussion about the supply chain?
Yeah, so we're talking a lot about signal to noise ratio. And GitBomb is fundamentally, I think, the best bet we have to provide really high fidelity signal to defense teams. Right? What we've done, and the name is a little bit weird, we're going to rename it because the first thing everyone asks me is, why do you call it GitBomb?
Yeah.
It's not Git and it's not an SBomb.
Yeah.
Right? But what we've done is we've taken the underlying technology that Git relies on, using a hash table to track changes in a project's code over time. And we've reapplied that same technology to track the supply chain of software. So when you take a C library, say OpenSSL, and you compile it with GCC, and then you link that into a project in a different language, and then that gets built into a Docker image all the way up the chain, right? What we're doing with GitBomb is building a hash table connecting all of those dependencies and building what we call an artifact dependency graph. The end result is you've got a binary. It's an RPM or Docker image, whatever it is. It has a fingerprint, a hash in it. That hash identifies the entire artifact dependency graph that went into build that. So now imagine if MITRE, right, or some other vulnerability authoring institute, right? They say, oh, here's the next Heartbleed. And we've traced it back to these source code files, which have these hashes. You don't have to scan through all these, big JSON and XML files for your SBOMs. You can just do a grep.
Wow.
Is this hash anywhere in the hash table for the environment I'm running? If it is, doesn't mean you are vulnerable, but it means you need to go investigate. It means that causative source code file was built in somewhere in the supply chain to the product you're running.
Okay.
That's what we're trying to do across all ecosystems, languages, build tools.
That's great. So it'll be much easier to find these vulnerabilities.
It's high quality signal for defense teams is the primary goal, and there's a bunch of other things that it enables as well. Okay. That's the main goal.
Cool. And that's open source?
It's fully open source. So we got a team working on it, a couple of proof of concepts right now. And the main effect I'm hoping to achieve from this is a small change in every language and compiler. Small goals.
Yeah.
But a little change in all of them. As long as it's done consistently, then we can get traceability across the whole supply chain.
That's great. Well, we'll put the link to the GitHub registry and
and gitbomb.dev website.
GitBomb, Put that in the show notes to this. Just one more thing. OpenSSF released a mobilization plan this year. Do you think? What are your thoughts on that? What are your hopes for that?
I mean, I've glanced at it. I haven't given it its full 52-page due diligence quite yet.
It's
but
short, casual reading.
Right? Yeah. As Aeva mentioned before this, it's good if you want to read something before bed. I think with any kind of framework or any kind of recommendation, it always gives people the feeling of, oh, something else I have to do.
Yeah.
And if they don't have the tooling in place to implement these new things that come out and that people want you to be, checkboxed on, then you're going to be way behind the power curve. So setting up something to make your security systems and automate those security practices is going to save you a lot of time when salsa or when something else breaks. If you can get a build system or some kind of automation system to maintain everything, you can do the same thing with your security infrastructure.
And the OpenSSF as a whole is putting a lot of effort into education, building best practices, building tools to support other communities. There's very little, code or projects that the OpenSSF itself produces. There's a few, but primarily what we're doing and what this sort of, the work stream that you're talking about is largely about is outreach to and coordination with all the languages, all the build tools, the rest of the open source ecosystem, sort of at its building blocks to help add security awareness, improve security capabilities of everybody.
Okay.
That's what it's about.
I mean, the awareness is the biggest thing, right? Like you don't go out on a big shipping boat without radar
Yeah.
or sonar, right? Like
Right.
you need some kind of visibility into what's going on around you to make decisions about a boat. And your enterprise is a lot like a boat these days.
Yeah.
It's kind of hard, a big boat at that. It's kind of
Yeah.
hard to turn around.
Yeah.
But you need to have that tooling in place to tell you something's out there, something's below here that you need to look at, or go back to the vendor that made it.
And be able to find it, right? If something in your
Like,
boat
find it
breaks
right
while
away,
you're at
right?
sea, you don't want to run around.
No, you don't
need
want to
know
hit the
where
iceberg.
in the engine room it is.
Right. Like
Yeah.
you don't want to hit the iceberg. You want to know exactly what happened and how to avoid it in the future, right? Like
Right.
that's the biggest thing. We don't want the whole compartment to flood. We want good, stable systems. So we need to put in the intelligence into our systems to make those happen for us in a lot of cases.
And that's as true in our open source projects as it is in our companies and products, right?
Yep.
We need better
Right.
tooling upstream as well.
And the Kubernetes community is a perfect example. They are constantly iterating on the release processes,
Mhm.
the way and how much things are automated versus, human involvement. And we see these debates happening inside, teams all the time. How, do we actually want continuous integration, or do we want to just stop right before release and say, push button, go?
Mm.
There's a lot of safety in that.
Yeah.
And, feeling. But the fact is, if you've built in all the tests and you've done it right, you should be able to just go ahead and deploy it automatically.
Yeah.
But then there's that, did we not test this one use case, or is this misconfiguration going to create a vulnerability kind of thing? So there's all this trepidation about just go live. Well, if you build all the things to safeguard it, you don't have to worry about that.
Yeah. Okay, so thank you. I guess that's all for now. Thank you very much, Aeva and Chris, for joining us.
Thank you.
Thanks so much for having us.
Thank you. And thank you again to our sponsor, AWS. And this has been Heather Joslin for the New Stack, and we'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.